Today, in this video, we're going to be talking about different kinds of number systems. Now, the number system you guys are going to be most familiar with is something you use on a day-to-day basis, and that is called base 10. Now, it's called base 10 because there are 10 numbers in it, 0 through 9. And once we get past 9, we have to increment and we go to 10. And it keeps going and going and going until we get to positive infinity. And of course, you can also go in the negative direction, but these are the 10 digits that make up base 10. So you might be asking yourself, well, are there any more kinds of bases? And yes, we only define base 10 as the way it is because we have 10 things. And we just have decided collectively that that is what 10 is. Now, what we make as 10 is actually kind of arbitrary. We can have any number of things be 10. So we can have, 5 things. We can say that's 10, and that would be a base 5 system. We can have 6 things be 10, and that would be a base 6 system. And we're going to look at a couple of different systems today. The 3 main ones that are used in engineering and computer science is going to be binary, octal, and hex, which are base 2, base 8, and base 16, respectively. So let's start off with hexadecimal, or base 16. So hex is probably one of the more easier ones to get a grasp on. So instead of ending at 9 for the number system and then starting to increment at 10, we actually end at 16. So we say that 16 is equal to 10. Now you might be thinking to yourself, well, what the heck? What is this going to mean for counting? There are only 10 digits that we know of. It only goes up to 9, and then we increment to 10. Well, in hex, we actually start using the letters. So once we get to 9, 10, as we would call it, is A. And then we go B, C, D, E. And then 15 is the hex equivalent of 9. And that is F. And then after that, we go to 10, which is really 16. Whenever we write a number in hex, we will usually denote it as in parentheses, we'll write a little 16 at the bottom. So if, I write like 12, in hex, that's going to be like that. Or if you're dealing with computer software, it could be 0x12. It just depends on what kind of a system you're using. Now, both of these are acceptable methods of writing down and denoting that you are, in fact, using hex. Now, the second kind of number system that we are going to talk about is the octal system. Octal system. And just like how we can change the definition of 10 to be things that are greater than what we would normally consider 10, we can also change it to things that are less than what we would normally consider 10. So here we have 8 things, and they are equal to 10. And we don't have to use any special new characters for this. We just, we count up 0, 1, 2, 3, 4, 5, 6, 7. Now this is important. There is no 8. 8 is replaced with 10. And then 11, 12, and so on. But these all carry on their own different meanings. So when you're writing things in base 8, you would write, if we write 12 in base 8, just put a little thing on the side there. And then that lets you know that it's in base 8. Now, in computer programming, this is not really something you see super often. I don't think I've ever actually had to use base 8 as much as I've had to use base 16. But it's still something, a thing that comes up every now and then, so it's good to know. And the final one that we're going to talk about is base 2, or as you guys might know it, binary. Now, it's called binary because 2 is equal to 10 in this case, and there are only 2 states, 0 or 1. So these are the only digits in our number system, 0 or 1. And counting is relatively easy. You have 1 or 0 and then 1, and then it goes straight to 10. So if we want to count to, let's count to 4. And actually, we can't count to 4 with only 2 bits because there are only 2 places. So binary is pretty straightforward. Usually, if you want to count to binary or you want to denote something in binary, you would write something like this and then put a little 2. So as you can see, kind of whatever the base is, that's the number that you will write down at the outside. And when you're programming, it depends on what language you're using, so make sure you kind of look it up on what you're using. But normally it's 0B for the base 2 or binary. So if you want to write something in binary in a programming language, you can write that, and then that will be interpreted accordingly. Now you got to ask yourself, why are these different kinds of number systems useful? I mean, we already have a perfectly good base 10, right? Why do we need all these other ones? Well, computers are actually based on binary systems. So that's the smallest number system that you can implement because of different things with transistors and with lower level kind of circuit design that we're not going to get into too much in this video. But the language of computers is in binary. So whenever you use a program or whenever you watch a YouTube video or anything like that, those are fundamentally ones and zeros broken up. So when we look at base 10 from this perspective, it kind of starts to make sense. If we look at all the factors that 10 has, we can break 10 into factors of 1, 2, 5, and then 10 itself. So, I mean, this is pretty good. We got 1 and 2 here, but 5 and 10, now 2 doesn't go into 5. 2 does go into 10. It goes into 10 5 times, but that's kind of a problem. We can't really have a number that we don't have a way to represent in binary. Now, obviously, you can represent 5 in binary, but it's a little bit more of a challenge. So with other higher number systems, we have base 8 and base 16. Well, if you look at these, base 8, its factors are 1, 2, 4, and 8. And similarly with 16, it's 1, 2, 4, 8, and 16. Now, if you know anything about the different number systems and also powers of 2, 2 to the x is some number, then you'll know that these are actually the powers of 2 in ascending order. So it's kind of a nice little coincidence there. So you have obviously 2 to the 0 here, 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4. And if you wanted to do this, you could do this as many times as you wanted to with as many different number systems as you wanted to. You could do base 32, base 64, and these would all kind of have the similar results where they're all easily broken up into base 2. And so because these are in base 2, it makes it a lot easier for computers to be able to break them down and interpret them because they don't have to worry about this pesky 5 here that is kind of hard for them to understand natively. So for them, it's a lot easier to break it down. And we can kind of go with an example here, and then we can finish off the video. So let's say we have a number in base 10. It is 19. Now, this is 19 in base 10, so we're going to denote it in 10. And we want to say, what is this going to be in hex, in binary, and in octal. So in hexadecimal, one thing we know is that in the number 10 is equal to the number 16 in base 10. So one thing we could use is that if 16 equals 10, then 16 plus 3 is 19. And therefore, we have 10 and 3. So in base 16, this would be 13. And it's base 16. So that's pretty easy to work with there. Base 2, it's a little bit more challenging. We know that 19, kind of following with our previous example, we know that this is 10 to the 1, and this is 9 times 10 to the 0, which 10 to the 0 is, of course, 1. This is 1 times 10 to the 1. So if we want to represent 2 in binary, we need to write out all the factors of 2. We actually don't write 0. We have 1, 2, 4, 8, 16, and there's 32, but we don't actually have to write that out right now. So 16 goes into 19 one time, and we have 3 left over. So 16 plus 8 doesn't work out. It's too big. 16 plus 4, still too big. But 16 plus 2 is 18, and then 16 plus 1 is 19. So in binary, this would be 1, 0, 0, 1, 1. We would write that, denote that that's 2. Or we could say 0b, 1, 0, 1, 1. And in some future videos, I'm going to go into a little bit more detail as to the strategies of doing this and kind of the tips and tricks of how to really, really get this done effectively. So last but not least, let us do base 18, or base 8 rather. Base 8, we know that 10 is equal to 8 in our system. And so because of this, we can use the fact that 10 is equal to 8 and say that, well, 16 then is equal to 20. And that because 16 plus 3 equals 19, then 20 plus 3 is equal to 23. So in base 8, 19 is 23. All right, so that is going to do it for this video today. I hope you guys learned a thing or two about number systems and how they're used, kind of the basics. In future videos, we're kind of going to go into the ways you can compute using binary and hexadecimal and octal, and ways that you can convert in between them. This is just kind of a warm-up, kind of a preview of things to come. So if you didn't understand it, that's okay. There'll be some more videos coming out in the future.